Welcome to today's lecture on Lewis dot structures. Before you continue this video, this lesson, what I want you to do is I want you to review two lessons that we've done already before, and that is the rules for Lewis dot structures, and then also number 2 lesson, and that is the exceptions to the rules for Lewis dot structure rules. Okay, so here we go. We're going to do Lewis dot structure rules. Lewis dot structures number 2. We're going to do the Lewis dot structure for boron trifluoride. So we got to first get the formula for boron trifluoride, and here is the formula for boron trifluoride. You see that there's that tri, just like a tricycle. That's why there's 3 fluorides. Okay, so here we go. The first thing that we're going to do is we're going to add up the total number of valence electrons. So you're going to be using your periodic table for this. We're going to find out what group boron is in, and boron is in group what? 3. That's fantastic. How many borons do I see in that formula? Only 1, so I'm going to multiply that 3 by 1. So fluorine is in what group? It's in group number 7. So that's why there are 7. And there are a total number of 3 fluorines. So we're going to multiply that 7 times 3. Then we're going to sum these numbers up. And that's going to be a total of 24 electrons. Now, I don't know if you remember from last time, but last time with methane's Lewis dot structure, we divided it by 2. We're going to do the same thing here. We're going to take the total number of electrons, which is 24, and we're going to divide it by 2. And then we get this wonderful magic number. That number in the yellow is 12 pairs of electrons. So it's the pairs of electrons that goes inside my bond blender, and I'm going to distribute them as is appropriate. Okay, so the first rule on the Lewis dot structure rules is to sum up the valence electrons. Then we're going to put the least electronegative element in the center. That is, the least electronegative is the one that's furthest from fluorine. So that hopefully is obviously boron. Boron is the least electronegative because it is the furthest from fluorine on the periodic table. Now, that is in the plus-like shaped pattern that's in the middle of the plus if you review the lecture on methane. And now the other elements, that is the 3 fluorines, go around the boron, just like that. So the next rule is to place a pair of electrons between the central element, that is the boron, and the outside elements, that are the fluorines, as bonding pair single bonds. So here, I'm going to do that here. Bam! So I got pairs of electrons in between the central element and the outside element. So I've used up 3 of my 12 pairs, and I still have 9 pairs of electrons left over. So my next rule is to place lone pairs of electrons on the outside elements. So I'm going to place a lone pair of electrons on each one of the fluorines. So 1, 2, 3, 4, keep on going until I used up the rest of them. And I have 9 pairs of electrons total remaining, and I have 3 sets of lone pairs around each fluorine. Now the next thing I'm going to do is I'm going to verify the rules, and that is I'm going to verify the octet rule. So if you put an imaginary circle around each element, in this case I've just placed an imaginary circle around the fluorines. The fluorines have 8 electrons, and that's an octet. Fluorine must have an octet. Now we're going to put an imaginary circle around the boron, and there it is. Now you should see that the boron does not have an octet. It is actually deficient in an octet, meaning it has less than an octet. But if you review the rules for exceptions to Lewis dot structure rules, and that is boron and beryllium can be electron deficient, and that is perfectly acceptable. So this is actually okay to be electron deficient, and that's why we're not going to do a double bond with the fluorine. Okay, so lone pairs of electrons remain as lone pairs of electrons, but bonding pairs of electrons, that is, those will be lines. So we need to rewrite this Lewis dot structure here. And here we go. Bam! This is going to be our final answer. And you should see that the boron is smack dab in the middle. And I got lines representing pairs of electrons that are bonding electrons. And then the lone pairs of electrons on the outside of the fluorine atoms, those are still dots. Okay, I hope you enjoyed today's lesson and look forward to the next lesson. Please review the rules on Lewis dot structures and also the exceptions to Lewis dot structures. See you next time. Bye now.